Have you heard about .NET Summit? .NET Summit 2020 will be held online on August 7th and 8th at 3 p.m. to 7 p.m. GMT plus 3. Speakers include podcast alumni Dylan Beatty and this episode's guest, Alexey Golub. Check the website for .NET Summit for updates. Regular tickets are on sale at €65. Get yours before the price increases on July 28th at .netsummit.by/tickets or check the show notes for a link. Hello everyone and welcome to the .NET Core podcast, the only podcast which is devoted to .NET Core, ASP.NET Core, EF Core, SignalR, and not forgetting the .NET Core community itself. I am your host, Jamie Gaprogman Taylor, and this is episode 55, Integrating with External APIs with Alexey Golub. In this episode, I talked with Alexey about two of his open source projects, CLI Wrap and YouTube Explode, and some of his top tips for integrating with undocumented and unstable APIs. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. So the first thing I want to say, Alexey, I'm assuming it's Alexey. I'm not sure on the pronunciation.
Yeah, that's correct.
Excellent. I'm not usually that great at pronouncing people's names, if I'm completely honest. But first thing I want to say, Alexey, is thank you ever so much for spending some time with me this afternoon because, I think you're an hour ahead of me, so it's a little bit later into the evening for you. So, I totally appreciate that. Everyone's really busy these days, even with, it'll date when we're recording this, but, most people are working from home, but even so, it's still quite late in the evening. So thank you ever so much.
Well, thank you for inviting. It's actually my pleasure. So yeah, it's great.
Okay. So for the people who are listening, would you mind giving us like a brief introduction to like the work that you do and the kind of projects that you work on and stuff?
Sure. Right. So I work mostly in .NET. So a .NET developer. During my work time or like daytime work, I usually work on cloud microservices like using Azure, AWS, ASP.NET Core, basically all the trendy stuff. When I come home, I usually work on open source. So I like to spend quite a lot of time on open source. I sometimes contribute, but mostly maintain my own projects. Yeah, so basically, I suppose most of my experience in development comes from my open source projects. And that's probably it, really. Also, I sometimes talk at different conferences, but I wouldn't say that takes too much of my time, so I probably shouldn't even mention that too much.
No, that's fine. I find it really interesting that closed source is something that a lot of people say that Microsoft and Apple invented it, and that open source is kind of how our industry started. And when people come to me and say, how do I get started? How do I get loads of experience? And I'm like, go and make something. Find a problem in your life, or well, maybe not a problem in your life, but a problem that you have with a computer or some kind of hobby that you like to do, and see if you can make something that is connected to it. Because then you're taking that problem that you have and breaking it down into all of these little requirements. And if you wanted to, you could go down the route of making user stories and all that kind of stuff, or you just make it, right? You have this problem, you want to solve it, you then go and solve it and give it to the world for free. People will then likely find it and go, hey, I've had this great idea. I've had this problem. Let me make a little tweak to it. And then you learn even more, right? It goes back to that idea of go and read source code.
Right.
All of the older folks, and I have a beard and I'm quite old myself, but all of the old guard all say, go read source code and you get better at it. And it's like, you can, or you can go and build something.
That's true. Like when I started, I didn't actually have a goal to, start doing open source. So it wasn't like, oh, I want to do open source. What should I do to start, right? So it was quite the opposite. I had, like you said, a problem that I could solve is programming, and I decided to do it. And once I did it, I thought maybe it could be useful to somebody else. And so why not open source it, right? I wasn't really intent on making money out of it. So why not just open source it? And that's how it started pretty much.
Sure. And I mean, we'll come on to it later, but there was something that I built today for my brother. He's had a problem. We were discussing it off air. One of the things he does is he does video game streams. And one of the ways that he does that is he streams up to Twitch, but also records locally at the same time. And the problem is that he's got a 2-hour long stream that's 7 or 8 gigabytes in size, and he wants to upload it to YouTube, but YouTube's saying, no, that's too big. So, I wrote a little app that it just wraps around FFmpeg and it throws all of those files at it. You run it in a directory, it will just re-encode every single file in that directory for him. And that's useful for him. It might be that because he's not a developer or he is very much an IT person, but he's not, the level that you or I will be at. And so some of his friends who are also streamers may find this useful.
Sure.
You talked a little bit about how sometimes you're involved in conferences as well. And I think that can be a great help to anyone in the development space, right? Like, even if you don't get up and speak, right? I was at NDC in London this year, and just walking around and saying hello to people and introducing yourself.
Yeah.
You meet so many people. You get all of these contacts, and somebody somewhere will say, hey, do you remember we talked about that? We were standing in line to get lunch, and you said there's this package that can do this one thing. Well, guess what? I need to know what that package was. Right? And then you go and save that person some time. Or they say to you, hey, I've had this great idea, and I think you're probably the best person to talk to about let's make it. And then you go and make it, right? And then you make millions of dollars, right?
It's true. Like, when I was just, working as a developer and starting out, I sort of viewed what I was doing and what other people were doing completely separate. Like, I thought we were in different bubbles sort of thing. And it's only when I started like going to conference as just as a participant that I started seeing those people face to face, that they're, physical. I can talk to them. I can ask them questions, that I started to realize that it's just a big community and we're all part of it. And it's actually a really nice and motivating feeling, I would say.
Oh, definitely. Definitely. And then I like to pick talks that are, some of them I pick because they are what I'm interested in, and some of them because they are literally nothing to do with what I usually do or any technology that I usually touch. So at NDC, I went to a talk about Apache Kafka. No idea about Apache Kafka. And I watched the person who gave the talk, Alan Underwood, talk about how great it was to run this thing with loads of Java and all these Docker things. And I'm like, I no idea what you're doing, but I totally get how this is really useful. And then I went away and looked into Apache Kafka, and it all just sort of fell into place. This is what it is. This is why it works, and all that kind of stuff. And whilst it's outside of the .NET space, it's given me an idea of similar things within .NET that I could use to solve similar problems rather than writing it all myself.
Yeah, that's actually very important. And I think that's one of the main reasons I always tell people to, learn another language or maybe multiple languages, because even if you're not going to like use it, at your work or whatever, you're going to learn how to approach the same problems from a different angle. And that actually makes you understand like the original angles from which you were approaching the problems a lot better as well.
Absolutely. One of the things I always say to the juniors is, okay, so you're learning C#, right? Go learn Java because it's semantically similar. And now that you understand C# and Java, go have a look at C++. And you can see where the ideas have come from.
Yeah.
I think Scott Hanselman has this idea of learning 3 languages: a object-oriented language, a functional language, and a scripting language. And then you can understand how you got from one to the other.
Right.
Because once you've learned those, then, you can see how the ideas for where did C# come from. Well, a lot of people don't like to say this, but C# came from Java. Java came from C. And you can see this big lineage, all of these languages coming together. And then, you get a better appreciation for the decisions that were made in putting these languages together. And you then start to see how, like, C# is very slowly nudging everyone into this functional direction, right?
There's also another thing is that when you're, let's say, writing in C# all your life, you might think, oh, this C# feature isn't that great. I wish it was like in Go or something. But then if you actually try to write that in Go, you'll realize that it's in fact just a trade-off, and you're going to, have other maybe disadvantages that you weren't aware of before. And, when you actually try that and look back, and you start to realize that, the design is actually really good, and there are trade-offs that were, taken for good reason. And it just changes the way your perspective really of the language and the platform, technologies, everything.
Absolutely, I agree. I really do not like duck typing, but I appreciate the things that it allows you to do, like the really quick prototyping and wonderful things like Angular and React have been built on this idea. So
yeah,
as much as I dislike it, because I really like to be able to go dot and see all of the properties, or to be able to set a variable to a specific value and know that it's going to be that value, and have the compiler call me an idiot if I try to do it wrong, you know?
Yeah, for sure. I think a lot of people would have been happier if JavaScript was statically typed from the beginning.
But then you look at the history of JavaScript and it kind of makes sense as to why it's not. Again, it's that trade-offs thing you were talking about earlier on, yeah?
Yeah.
There's that famous story of JavaScript was first created in 10 days. Makes perfect sense to me. You got 10 days to do it. Okay, let's not bother with a typing system. Yeah.
Yeah, we'll implement it later. Just, if we need it, we'll do it.
One of the things that I really wanted to talk to you about is your library CLI wrap.
Yep.
I used it this afternoon in an application. I kind of hinted at it earlier on. And the application I threw together was maybe 14 lines of code. And it is grab me all of the MP4 files in this directory and throw them all at FFmpeg and output to the screen what it's doing. It's brilliant.
Yeah.
Whereas previously I'd have to system.process.new process info and all that kind of stuff.
That's actually almost the same reason I created in the first place. So I was doing something with FFmpeg as well. I was mixing streams together. So I had two streams, audio and video. I wanted it to be combined. And also, like you said, I started this system diagnostics process, the built-in.NET class, and tried to use it to run it. And I Googled how do I, for example, read the std out or std-err, how to wait for it to complete. The first issue was that it's asynchronous, right? So wait for exit, it doesn't return a task. And a process being, naturally an asynchronous operation, you would want it to be expressed as a task. So it didn't do that. On top of that, when you try to read std out, std-err, if you do it incorrectly, which is really simple or easy to do, you'll get a deadlock. It's very simple to get into a deadlock scenario. So basically, I spent way too much time trying to get it to work. And I realized, okay, it has to be simpler. And if it's not already simpler, I just have to make it simpler. So that's how the project really started.
Just to give a little bit more background information, my understanding of CLI wrap, having used it today, is that it kind of wraps around calling command line stuff. So, we both talked about the example there, we're using FFmpeg, but maybe we want to use something else like disk utilities or something like that.
Git.
Yeah, exactly, right? We want to pull some code from Git in a programmatic way, right? I know that the goal was to sort of simplify that original task that you had, but was that literally the only thing you were trying to do?
It always started with a single task, right? And then it starts to evolve. Yeah, basically, I just wanted to make my life simpler for that particular scenario, but I realized that it's very generic, right? So I just want to launch a process, and I want to treat it like a CLI. So I don't expect it to have a window with buttons. It's just gonna be a command line application. And I just wanted to run until completion, and I want to know what it wrote to std out, std-err. Basically, that was it at the beginning. And just like you said, a lot of scenarios fall into that description. For example, you can use Git or kubectl or some other CLI that you want to automate. And it also makes sense because, when you want to use some code like FFmpeg, why are we using FFmpeg as a CLI? Because there is no library in .NET for doing that sort of thing. So instead of, trying to write a library for that, which could take years probably, you could just take FFmpeg and wrap it and pretend like it's managed from the beginning, right? So you can just hide it behind a layer of abstraction. And I thought that was really cool. So you could just literally take a binary and pretend it's part of, a library or something like that.
Like you say, you could spend years building a .NET wrapper around something like FFmpeg, and then as soon as the API space changes, you have to go back and rewrite everything. Or you're then locked to distributing that particular binary, that version of that binary with your application, which then potentially has licensing issues. So, yeah, I totally get it. The only dependency then is that the consumer has whatever library and knows the API. Presumably they would know it anyway, because all they're doing is automating it, right?
Right, yeah.
And, I'm sat here thinking, well, I could totally do that with something like, I use Hugo a lot for some of my static sites. Mm-hmm. Maybe I could use it with Hugo, right?
Right, yeah.
And just run a little cron job once a day to just rebuild my sites or something.
Yeah, potentially. So
we talked about, how it came to be. Have you only used it with FFmpeg, or have you used it with, not that FFmpeg isn't complex, but a much more complex situation?
Actually, even as with FFmpeg, I used it in pretty complex situations. Like for one of the cases was when I had an HTTP stream that I obtained through HTTP client. I wanted to just pipe it directly into FFmpeg without having to save it to a file first, so that it's faster and you don't have to waste space on the hard drive and whatnot. And I could actually do that with CLI wrap because you can pipe streams and you can pipe commands into commands and you can do all kinds of crazy things. And that was actually probably the most difficult thing to design and implement. And it wasn't until version 3 of the library that actually I think I got it right, because I'm not sure. For maybe it turns out that it doesn't work for some scenarios, but so far it's been really nice. Oh, and another thing I wanted to mention is that I'll use it a lot for testing, actually. So I have like one other library, which is an auto-updating library. So it basically does what Click Once or Squirrel does, but it's much less opinionated. So you basically take a dependency, you say that, okay, take this GitHub repository, look for latest release, and if there's something new, just replace it. And to test it, I had to make another application that would sort of be the dummy application that would get updated. And to automate all that, I just used CLI wrap. So it actually saved myself a lot of time just doing that.
I've made open source packages in the past and then found, oh, wait, I can use this to make that, and you end up building this sort of map of, oh, cool, I have this. No longer have a hammer, I now have a screwdriver. I can screw these screws in, and then the screwdriver will help me build a lathe or something. And you end up building these bigger tools.
Yeah.
And the way that I did that was, when I first got into ASP.NET Core back in the day, was I thought, well, I want to create the OWASP recommended security headers. And I thought, well, how am I going to do that? Well, let's have a look at how headers are injected. Oh, it's middleware. Right, okay, so let's build a middleware. And so I taught myself how to build middleware. Now I've got like 4 or 5 different ASP.NET Core middlewares just laying about the place. And almost every project I start that is either a web API or some kind of web UI has all of those middlewares installed, just because I'm like, hey, look, you can see it in use, But it also helps with the keeping those NuGet package installed numbers.
yeah, that's true. That's let's face it, that's the main reason.
Yeah, right. That's it.
Why we do it. Yeah.
Yeah. We mentioned earlier on about the trouble that we would have for creating an API that talks to some service or some application, and that constantly changing, or rather constantly evolving. We said that, with FFmpeg, if you wrote a .NET wrapper around it and then they changed the API, you'd have to go back and revisit, right?
Yeah.
And I happen to know that you've been working on an application called YouTube Explode.
It actually has a funny history for that name. I wanted to make an experiment, right? So I just wanted to download a video off of YouTube. And I thought, how hard can it be, really? And my experiment started from Googling, obviously. And the first few examples that I've seen were all in PHP. And in PHP, there's this function that takes a string and splits it, and it's called explode. And I saw that function everywhere because, you have a lot of URL encoded data and you split by semicolons or commas, I think. And then you use that function all the time. So I thought, oh, that's a good idea for the name. So I'll call the library that instead.
So is it literally just a YouTube downloader, or does it do lots of other things? What's it do?
It's actually hard to explain what it is in one word, but it does a lot of things that you would normally be able to do when you open YouTube in a browser, but you wouldn't be able to do through the means of the API because those are not provided. So if you were to download a video, or you wanted to get the videos in a playlist or closed captions for a video, all those sort of things, you could do that with the library, yeah.
Okay, so it's like a multi-tool for YouTube then.
Yeah, essentially.
That's interesting. So the reason I brought that up is because we were talking earlier on about APIs are constantly changing, right? And if an API is closed, then it's always going to change, right? Because it's up to the person or the people who are maintaining that API. So my question to you is,
how do I do it?
Yeah, right. How do you do it? And why? Right? Because I can just imagine you get something working, you push out a build and it works, and then 30 seconds later, everything's broken.
That happens. I could answer why is because I didn't really think about it. When I started, it sort of just was an experiment. I didn't think I would have to maintain it for, 4 years now, I think. But as it kept going, I also had these problems that sometimes they would just break. and I would have to fix it, and people would create issues saying when it will be fixed, why is it not working? And then I started thinking, how can I approach this problem in a way that I can avoid making fixes as much as possible, so that it works most of the time or as long as possible before it breaks again. And there are basically some things that I've found that are, I would say, good approaches to that. So let's say you're building let's say just a normal client to an API that has a solid versioning system, and you're sure it's not going to change. What would you do? You would probably just make an HTTP client. You would use system text JSON or Newtonsoft JSON, deserialize to your models and stuff like that, and that would work perfectly. And obviously, when the API is changing all the time, or when it's not supposed to be consumed from the outside, that won't work, right? Because as soon as something changes, your deserialization breaks. And I found that it's actually a big problem when you rely on a specific, when you bind the model of your domain entity, essentially, let's say video, right? It has some fields, maybe a title, author, and stuff like that. When you sort of bind that logically with the response you get from the API, you're going to have problems if that API changes a lot. And you get that with deserialization because it maps them one-to-one, right? So, of course, there are converters and stuff like that, but essentially it's still one-to-one mapping. And the first thing I realized that I could actually, if I could sort of break them away or break them apart so they're not coupled as much, then I probably would be able to save myself a lot of headache. So because of that, I'm not using deserialization at all. So I'm dealing with JSON, but I'm always doing all the parsing manually. So I have this model that I'm telling my consumers that I'm going to return. But in reality, I might actually make multiple requests, or I might take this field from one place or this field from another place, and it's actually hidden behind a layer of abstraction. And it gives me this flexibility that, if that changes, I don't actually have to, make a breaking changes in my library. And also because of that, I can implement multiple layers of fallbacks. So if let's say I need an author of a video, right? But if I make this request, it might be there, but let's say 2 out of 10 cases, it's not there because there are multiple types of videos and they have different constraints or whatever. So I would instead go to another request or send another request and get it from there, but it's going to have a different name. And it would be impossible to do that if you were just deserializing stuff.
I like that approach because we're always, all of us, in our day-to-day lives, unless we're doing something wonderful like making video games or whatever, almost all of the time our code talks to an API which more than likely talks to another API, which then eventually will maybe talk to a database and then will talk back to us, right? So I like this idea of what if the API that I'm consuming breaks. In the pragmatic programmer, we talk about design by contract.
Yeah.
But what happens when that contract breaks? I like the idea that you've come up with. I will have my model. I will take the raw output. I'll get the bits that I need. And then if I need something else, I'll go back and get something else. It's kind of like there is a pattern that I've been using a lot recently for Entity Framework where I have a generic repository. So rather than get me the entity and all of the related entities, I'll get the entity and all of the IDs for related things. Because 9 times out of 10, I've actually seen this in the wild where someone will create a model for logging in, right? You put in username and password, and it will go to the database and it will get the user data. But there's also the navigation properties for orders and addresses and payment details, and all of that comes back. And it's just to check whether they can log in or not.
This is actually an important point as well that you brought up, in that it's when you design this contract that you're essentially guaranteeing your consumers that you will return, you have to really be confident that you're always going to be able to return all of it, right? And when I started, I didn't realize that well enough. So I obviously I wanted to do that, but I didn't know what kind of fields would go together, which ones wouldn't. Because when I started, I looked at the internal request that YouTube's front end uses, and I saw that, for example, this request returns all this kind of data. So I just put it in one contract that I promised everybody I would return. But then they suddenly removed some of the fields or moved them to some other place, and I have to make another request to get it. But then I realized that those fields weren't really that important for like another heavy potentially request, and it would have made sense to like separate them from the beginning. And from that perspective, like for example, take a playlist, right? It has videos, but playlist also has its own metadata. So it has like title, again, author, date when it's created and stuff like that. And logically, you would think that, okay, I want to get the playlist, I will get the metadata associated with it, but I also get the videos, right? But that's probably not a really good idea because, again, those are two essentially unrelated things, like unrelated even concepts, I would say. And it actually saved me a lot of time that I separated them, because then I could think of them separately. And if I needed to like optimize one of the requests, I don't have to worry that I might not have enough data for the other, sort of model that I'm trying to return. So another thing I guess taken away from it is that you should really think hard and limit like the scope of your models as much as possible. Even if it's very fragmented at the end, like you will have very little data in one model, you have to make many requests, it will actually save you headaches. Also because like even if one of them breaks, the other one might not break. Your playlist get videos might break, but playlist get metadata might still be working. And let's say half of your users are only using the metadata part for some reason. And then you'll have half as many issues on GitHub. So it really makes sense.
Absolutely. This episode of the .NET Core podcast is sponsored by configcat.com. Configcat is a feature flag service. It has a central dashboard where you toggle your flags visually, hide or expose features in your application without redeploying code, set targeting rules to allow you to control who has access to new features, easily use flags in your code with config.cat libraries for .NET and 9 other platforms. Get builds up faster, test in production, and do easy rollbacks. Release new features with less risk and release more often. With config.cat's simple API and clear documentation, you'll have your initial proof of concept up and running in minutes. Also, train new team members in minutes and don't pay extra for the team size. With the simple UI, even product managers can use it effectively. You could try it out with their free forever plan, or get 50% off of a paid plan with the code NETCORESHOW. That's NETCORESHOW. Release features faster, with less risk, with config.cat. Check them out today at configcat.com. I do like the idea of splitting a request into, like, let's use that example earlier on about a user with orders and payment details and billing details, right?
Yeah.
Let's imagine we're looking at Amazon, right? You're looking at your orders page. Nowhere on that page does it list your payment details, right?
Yeah.
Because each of those orders could use potentially different payment details, and they could each use potentially different billing details. So why pull all of that data back, right? Make it the smallest possible requests that you can. And the majority of things, if you're working within the browser or if you're working with a like HTTP client, you can parallelize those almost infinitely, right?
Yeah.
I mean, there is an upper limit on the number of tasks and how much CPU time you can actually use. But for the majority of cases, you'll be able to parallelize it and make it more optimized by having it work in parallel. You've got a customer ID or you've got a user ID. Okay, go get me all of the orders. Now, whilst that's happening, go get me all of the payment details, or go get me all of this thing, or go get me all of that thing, because you don't need all of it all at once, because like you say, you'll very rapidly run out of memory, or you'll run out of bandwidth, or you run out of API requests if you're doing it all as one big lump. I mean, I mentioned earlier on, you put a request into an API, you may have to sit and spin until that API puts in a request to 4 other APIs.
Yeah.
And I hate to use buzzword bingo, but this idea of I'll request just the information I need and then I'll do something else sounds awfully like a microservice, And microservices are good and they have their uses. Not everyone should move everything to them. But this idea of taking an API for what is essentially people think as an important feature of the internet, YouTube is kind of an important feature of the internet.
Yep.
And breaking that down into a microservice makes perfect sense to me.
Yeah.
Maybe you just want the comments on a video. To get just the comments, do you need to get the video itself?
It's very important to understand that straight away, because you might think like, okay, I can actually get the comments together with the video. So why make the second request at all? Like I could save time. I could maybe even make the performance better because I would make only one request. And then you do it. and then suddenly they remove the comments from that. It actually happens very often. So I get things moved across, the API boundaries all the time.
Mm-hmm.
And then you're stuck because now you have to make 2 requests, but some people might not want the comments, but you're now forcing them to wait longer because you're now making 2 requests. And if you did split it ahead of time, because those are logically separate, you wouldn't have that problem anymore.
Exactly right. And like we've said here, that it makes sense to do that, because if you're working with some black box API like the YouTube API, or maybe you're using an undocumented API, which is more than likely the case, you are brought in to work on something, and there's this black box API sat there, and there's no documentation because it was written 15 years ago.
Mm-hmm.
We're seeing this a lot in the COBOL space. There's a lot of banking and finance applications that were written 30, 40 years ago that quite literally the developers are not alive anymore, right?
Right.
And they need new features adding, or they need to fix a bug, or they need to add this support to something.
Funny you mentioned Netflix. I actually heard a story from someone on the conference, now that we mentioned networking and stuff. So he was actually working in one of those companies. I'm not sure whether it was Netflix or not. And they had an API that was used across their mobile app, their TV app, their desktop web browser app, and stuff like that. And so it was a lot of services depended on it, but it also had this weird API structure where it would return different responses on one endpoint that you can't just deserialize it to one thing, because sometimes it has those fields, but sometimes it has some other fields. And nobody was willing to change any of that to accommodate just, REST standards, something like that, because it was used by everything. So the developers have to adapt and do exactly essentially what I'm doing. And they actually do that for their job. So it's a real use case that exists.
So this is the potentially thorny question, right? At any point in our development career, we've all worked with these APIs where there's almost no documentation, or there's some undocumented effect, right? There was one API I was working with within the last 2 years, I'll say, where you would post data to it and it would respond with an HTTP OK, but inside it would have a status code of 500 and an error message. What I'm getting at there is that obviously you've received this OK back, but it doesn't necessarily mean that it's OK, because you've got to then literally look at the message, right? Or I've received a 500 with an OK inside of it.
Yeah, that's actually tricky. One of the things I'm also kind of dealing with is because I don't always have to have JSON in response. Sometimes I have to also scrap some HTML or data from some HTML pages. And because of that, for some reason, when you have just pages returned to you, they don't always have status codes that indicate whether they were actually successful or not. So you have to also look inside of it to figure out whether the response was actually a successful response that you should try to parse, or maybe you should retry and get another one. And I also, one of the things I did to make this simpler is I made a sort of a middleware I have this, request pipeline. So I inserted a middleware for different kind of request. And, if it knows that it's a request to this URL, it knows that it could return at 200 OK, but it might have something inside. So it first looks into it. And then if it actually isn't successful, it tries over again. So from the higher level, you don't even realize that's happening. So you have those, it's not redundancy, what's it called? Resiliency, I would say, yeah.
Like we said at the beginning, working in these sort of open source areas, it helps to, more than likely, your work on the YouTube Explode has affected how you think about accessing external APIs in your sort of day-to-day, I am being paid to make this.
For sure. Sometimes it's just when I have to make a request, I'm should I really deserialize this to a class? I mean, maybe I should just use linked you to JSON, or just parse it manually. It would be safer. I'm really starting to ponder it every time.
Sure, I totally agree. I don't want to say this in any way, in a bad way, but I have noticed that Newtonsoft JSON has become it's required to do any kind of .NET work.
Yeah.
It's one of the reasons why I think Microsoft hired James Newton King. It's because your library is required to make it all work. In fact, for the longest time, it was a dependency for ASP.NET Core. You needed it to actually receive the requests, so they would handle the conversion to and from JSON for you. I mean, it's a well-written library, I'll say that.
Yeah, for sure.
But there's a lot in there that someone will pull in that, and it's maybe a 15, 16, 17 megabyte NuGet package. and that's pre-compiled and optimized, and they're using deserialize of type T, and that's it. At which point you may as well use system.text.json, or like you say, hand roll the parsing yourself, because if you need it to be as small and tight and just deal with this one object, why not write it yourself, right?
Right. One of the solutions to the problem when you have to like a response from a service, and you also want to return something to the consumers in a different schema, one of the solutions is to have like a DTO object, right? So you have that, and you also have a separate response. But I really don't like this duplication where you have 2 layers, sometimes even 3 layers if you include the entities on the database side. So by just doing the deserialization manually, if you have, for example, a property that has a different name on the other class, you could actually do the same, but you don't have to create and duplicate all those properties all over the place.
Sure, because then you end up with, if you have multiple copies of a DTO and then a database entity and all these hundreds of different things, you end up with, well, I have to change it here, and I got to change it there, and I got to change it there. And then if you're unlucky enough to be using, say, a mapping library like, say, AutoMapper, and don't have unit tests for that, it blows up in production.
True. We actually had a case at work where our contracts were like in a separate project that was pulled using submodules. And then that project was also used in another project. So actually changing something in one model in the contracts was very difficult. So you had to make a change on the one client, I would say. Then you have to make the change on the contracts and on the other service. And you have to pull the submodules. You also have to like publish some NuGet packages. At some point, I remember I had to make changes in 6 projects just to do that. It was crazy.
And that's the worst, isn't it? Because like, if it is an API that you're calling, it fails when you run it. You can't, whilst building, you can't put in an HTTP request to make sure it comes back, because then you're writing 3 times as much code just to actually test that the value comes back correctly. So unless you write like an integration test, but then it gets a bit wobbly, because if you do write that integration test, but it is broken, is that a failed test? Is that a failed build? And then, like you say, you pull the Git submodule and it's changed again, or that submodule requires another submodule which has changed. It's turtles all the way down.
Right. Whether an integration test failing is like a bug, like you said, or something else failing, it depends like on the responsibility on the service, like what it is actually supposed to do. So for example, in YouTube Explorer, I also have tests that verify that whatever it is they're doing, they actually can do. So if YouTube changes something, they start failing, right? And that's actually a good thing. It might not mean that there is a bug in the library. It most likely doesn't mean that. But on the other hand, I get this early warning that one of the, let's say, 50 methods doesn't work anymore for this particular video, because sometimes like 15 videos, you might get an error in one of them. And if that's like your scenario, if what your service is doing is actually something like that, then integration tests are much more important than any kind of test, really.
Definitely. In that case, do you have any specific advice to people who are maybe looking at either they haven't come across it yet, or they already have and they're struggling with it, or they've already dealt with it? What would be your advice for dealing with these kind of black box APIs? Is it just a case of split your request down to as many small pieces as possible and hope that it still works? Or what's the Alexey way of surviving creating YouTube Explode?
Yeah, so in retrospect, I would say that you don't want to think about how all those like requests you can make actually look and the responses. You want to think about what you want to give to the users. And from that perspective, you can model your API like as if it was wrapping a REST service. So for example, in my case, I took inspiration from OctoKit, which is a library for GitHub. And they have this sort of layered clients that you can like go to branches and there are requests related to that. So I took that inspiration and I actually made the same thing. Even though the actual API I'm talking to is nowhere close to being REST, I model it like that. And I try to make my models the way I want them to be. And then I adapt the request and parsing so that it fits into that model. So not the other way around. Because I realized that I want to reduce the risk, right? So I want to also, like you said, split them apart so that they're as small as possible. And how do you do that? You basically think about, for example, what you're dealing with. If it's a video, there could be, like you said, comments. There could be something like title, rating or something like that. you can think about it to yourself, like, is a comment something you would always want to get along with the video? Probably not, right? Would title be something you always wanted to get with the video? Probably yes, because it's one of the most important metadata properties. So you probably keep the title on the video, but split the comments to some different requests on something like that. And by doing that, you're essentially making it more modular and without losing usability because of that. And if something does break, which eventually happens, it's easier to fix, and your users don't suffer as much because the other requests might still be working, and it's a lot better this way.
Sure, I totally get that. So one of the things I do for one of my many little web projects is I allow embedding of YouTube videos. If you embed a YouTube video, you don't care about the comments because you're not going to read them.
Right.
All you need is an image to display with the YouTube play button. And when you click the play button, it needs to start playing, right?
Yeah.
You don't need view count. You don't need thumbs up and thumbs down. You don't need comments. You don't need the related videos. You don't need what playlist it's in. You just literally need the smallest piece of data. And like you say, if, for instance, that API breaks, but the comments still break, you can still display the comments.
Yeah.
But you can display maybe a little message that says, unable to play at the moment, please try again in a minute or something.
Mm-hmm.
If I'm completely honest, I think this advice extends to not just I've written an API which scrapes an API, but like I mentioned earlier, let's say you've got Entity Framework or Dapper or Debonair or something that you're interacting with a database via an API, right? You want to make your requests and responses as small as possible. Doesn't matter if you fire off 1,000 of them, as long as they are just pulling back 2 or 3 bits of data, because the data that you receive may be completely unrelated. You don't want to pull it all back at once because then you're wasting time waiting for all of that data to come back, right?
Yeah.
That's the whole reason why parallel computing exists, right? It's the whole reason why we have multiple cores and hundreds of threads on our computers.
Sure, yeah. For sure, it extends to other scenarios as well. So it's something, like one of the things about programming that I both love and hate is when you keep working on something and you have the sudden realization, oh, that's how it's supposed to be. But then you look back in retrospect and you think to yourself, it was actually very obvious. That's one of the main principles. Why wasn't I doing it from the beginning? And splitting things up, like you said, is one of those things that just make sense most of the time. But somehow it might not be obvious from the beginning. So really depends on the context.
Absolutely. I don't know whether it translates across, but in UK English, we have this phrase, you can't see the wood for the trees. So wood is like a wooded area, and you can't see that because of the trees. You can't see the obvious answer because you're surrounded by all of this detail.
Yeah.
I don't know whether it fits 100%, but I feel like it kind of does.
I suppose so, yeah.
I mean, it's like all metaphors, right? It doesn't fit perfectly, but it kind of works a little.
Yeah.
It gets the point across.
And it's also funny because I was just, writing in C# for the longest time. And then I started learning F# for about a year. And, when I had problems in C#, I would think to myself that, that would probably be easier to solve in F#. This sounds like a functional programming problem. And then when I actually started doing stuff in F#, like I said earlier in this recording, that I realized that it's just a different approach. But because of that, I realized that, all of those things that made me think that there might be a better approach didn't make sense because I lacked all this, perspective that I didn't have before. And it's kind of the same with just the principles you take away from a project, like any kind of experience. For some reason, it always seems obvious in retrospect. And sometimes it's even a little bit embarrassing. You want to tell it to somebody and you start talking about it. And then you think, maybe they'll think I'm stupid because that's how you're supposed to do it, right? But yeah, that's how it is, I suppose.
Well, I mean, if you've never experienced it, then you don't know.
Yeah.
And the way I feel about it is I always try to question my assumptions. Rather than saying it has to be done this way, I'll ask, well, why does it need to be done that way? Is there a business reason for it to be done that way? Is there a constraint in we talked about API contracts. Is there some API contract that states it has to be done that way? Is it a framework or a tooling or a language specific thing? If not, has there been exploration into other ways to do it? And if there has, what were the results?
Yeah.
And if there hasn't, why not? Let's take 5 minutes and figure out another way to do it.
Right. Something that happens sometimes is when you think that there might be a better way to do it. So you start on this, I guess, goose chase of a better way of doing it. But then you realize that the first way you found that was actually worse in some other way. So you started looking for a different way, and you keep going, and essentially you end up with something that's very similar to what you started. And on the one hand, you realize that, okay, the first design wasn't that bad. On the other hand, I wasted maybe a week trying to figure out how to do it better. So it's kind of like a mixed feeling. On one hand, you've gained experience. On the other hand, you also didn't really make anything better.
I can understand that. From my point of view, if I ever end up in that sort of situation, I'm always trying to do things as effectively for the people that I'm working for and with. I try to stick away from the word productivity, because for some people, productivity is I have a Kanban board and I'm moving a post-it note from the left to the right, or in different cultures from the right to the left. And that's all I care about, is I move the post-it note. That's what productivity means. Whereas for me, effectiveness is how can I create a solution to the problem, not move the code across. I want to create the solution that the customer, the client, whoever it is, thinks that they want. And if that means it takes a week for me to figure out that where I'm going is wrong, that's still effective, because as long as I document, hey, I tried this way and it didn't work, then that means that maybe other developers in the future will come to that and go, right, he said it didn't work because he went this way, so we'll go back this way. Kind of makes sense to me anyway, that as a society, we haven't gotten this far in life by people just accidentally figuring out how electricity works. It has always been experimentation. What happens if I do this? What happens if I do that?
Yeah.
And that totally makes sense. And
most of the time, nothing happens.
Exactly right. Exactly. But like, when I first got into the study of programming, just outside of high school days, my tutor at the time said, the one thing you need to remember about programming languages and frameworks and stuff is that it's like playing with Legos, or whatever kind of local equivalent of Legos is. I don't know whether I'll get a copyright strike for that, but it's like playing these toys that click together to make something, and they're completely modular, right? If the sorting algorithm you're using isn't fit for purpose, maybe it's, I don't know, ON squared or something, and you want to get it ON, then go have a look at other sorting algorithms. And the only way you'll find that out is to literally go and play with the other sorting algorithms, or to play with other APIs, or to play with other bits of code.
Sure. Yeah.
How else are you going to know? So I always see that if you end up going down a path, like you said, you end up on a goose chase, as long as you have learnt at the end why it was a goose chase, that's a net positive. Always.
For sure. It's actually also interesting because, like you said, like if your sorting algorithm isn't fit for purpose, you might look at some other solutions and approaches. And sometimes you might not find, what something is actually better, or something that's fit for your purpose. And that's how you also end up creating something new. It's also like going back to CLI wrap, that's how the piping thing actually was built. And that I looked into how it was done in .NET and other platforms. And I really didn't like any of them for different reasons, really. So one of the main concerns I had, that I wanted to separate the construction of the pipeline from the execution, and none of them really did it the way I really wanted to be. And it was really like this goose chase I was talking about, that I went back and forth and around trying to figure out how should I design the API, because I wanted it to be both simple for very simple use cases. For example, when you don't want to pipe anything, just run, and it should work very simply. But on the other hand, I wanted to make the more complex stuff possible, and ideally also simpler than otherwise, right? And just designing APIs. And one of the things that I really like about open source is that I can just turn an idea into a library or a project. And suddenly, after a few months, there are people who are using it. And suddenly I have to start thinking about it from a little bit of a different perspective. Like, what my users would want from it? How would they use it? And with CLI wrap, I sort of realized that most of the people don't really care about piping. Like you said, they just want to run a CLI application and make sure it doesn't deadlock, or just output stuff and it works. But on the other hand, there are 10% who would want to make complex pipeline scenarios and stuff like that. How do you actually make something that fits both of the use cases without hurting usability in either case, really? And it's really difficult, and it's really fun and interesting to do that.
I completely agree. I have a love-hate relationship with issue reports on any of my open source projects because I'm like, I love that someone's found this bug, but I absolutely hate it.
Yeah, that's true. It's like, thank you for using it, but...
If you could have not reported the bug, that would have been better.
Sometimes somebody may make a pull request. On one hand, you think, oh, cool, somebody actually contributed to my project. But then on the other hand, you realize you have to review it. You have to maybe, brainstorm different designs to help figure out how to fit this feature into the whole project. And when you start thinking about it, there could be actually a feature that you personally wouldn't even use, but somebody else wants it. And from that perspective, it could be very difficult, yeah.
Sure, yeah, sure. So where is the best place to find out more about both CLI Wrap and YouTube Explode? Is it just GitHub?
Yep. I try really hard to make comprehensive READMEs. So yeah, I write a lot of stuff there. If for some reason there are no answers to what you're looking for, you can always message me on Twitter and I'll reply. Obviously, I'll help you. So yeah.
Cool. Okay. They're open source, right? And you mentioned earlier on about pull requests. Are you actively accepting pull requests? The reason I bring that up is that I know that there are a lot of open source libraries where you can make a pull request and they immediately deny it. No, that's not where this project is going.
An ideal scenario is when the user who wants to contribute opens an issue first. And that's a good opportunity to discuss whether this is something that actually needs to be addressed. Because like you said, it might not be something that the project needs because the maintainers think that it wasn't designed for that. And the person can save a lot of time by not trying to make a pull request, by just asking whether it's something, that the project might need. And on the other hand, it's also a good place to discuss how you would actually want to fix that or address or implement the feature. So you could discuss the API, the lower level implementation. And if that happens, then, everything is perfect. That doesn't often happen because people are kind of random. So some people still make pull requests out of the blue. Often, sometimes I have to close them because that's, one of the reasons, because this is probably like a lot of overhead for something that I don't really see a lot of benefit in, stuff like that. So it's really, pull requests are really, I have a love-hate relationship with them. Because on one hand, it's something somebody wants to contribute. On the other hand, once they merge it, it's suddenly your problem. And you have to think whether you actually want to take responsibility for that. And on the other hand, also, if you decline, you might be that open source developer that declines pull requests. You don't want to be that either. So it's really difficult to thread this balance. And at the end of the day, you're just doing something that you personally just want to do for fun. And you also have to take into account this emotional aspect of it, like balancing your answer perfectly so it doesn't, offend the person if you're trying to decline a pull request or something. On the other hand, you also have to do this. So it could be really stressful,
Sure, I totally agree. Okay, so what about catching up with yourself then? What's the best way for folks to...
Twitter, and I also blog on my website. I mostly just write about things that I find interesting or niche. I really like covering very niche topics. Like my most favorite one was probably how I discovered monadic parser combinators, like how you can compose parser using functions. And, this is the kind of stuff I write. So if you're interested in that, you can check out my blog as well.
Cool. Okay. Excellent. Well, all that really remains to say is thank you again for taking some time this afternoon. This was a really engrossing conversation. I really enjoyed it.
Thank you.
There's so much about API design that I hadn't even really consciously thought about, and a lot that I hadn't even crossed my mind. So I think I'm going to take a lot of points from this and go have a look at YouTube Explode and see how that's breaking things down. And maybe my next API will be a lot smaller.
Thank you very much for inviting me. I'm actually really glad that you found that very useful, this discussion. So I'm really glad to be here.
Awesome. Thank you ever so much.
Thank you.
That was my interview with Alexey Golub. Be sure to check the show notes for a bunch of links to some of the stuff we covered and a full transcription of the interview. The show notes, as always, can be found at .netcore.show, and there will be a link directly to them in your podcatcher. And don't forget to spread the word. Leave me a rating or review on your podcatcher of choice. Head over to .netcore.show/subscribe for ways to do that, and to come back next time for some more .NET Core goodness. I'll see you again real soon. See you later, folks. The .NET Core podcast is a production of RJJ Software Limited.